is the easiest law. This basically means that if there is any action occurring, means suppose a force has been exerted or a particular action is being occurred. So for that, an equal and opposite reaction will definitely exist. Like I'll give you an example. These are two blocks. This is A block and this is B block. Now see, suppose A has exerted, when they are placed in contact with each other, none of them is moving, right? None of them is moving. Reason? Because whatever force A is exerting on B, see, suppose there is a force that F is exerting on B, force of A on B. Exactly the same amount of force is being exerted on by B on A, right? So FAB is exerted on one side and equal and opposite. When I use the term equal and opposite means FAB, this is equal to minus of FBA. This is equal in magnitude and opposite in direction, right? Now see, if they are exactly equal, if the magnitude is exactly equal, then why are not we able to cancel it? If it's 5 Newton over here, and it's 5 Newton over here also, and the direction is also opposite. So both of them should cancel. It's equal also. None of them is the heavier force, or the signs are also, the directions are also different. So still we are not able to cancel both the forces, right? The forces that are occurring. Reason behind is that, see, when force FAB occurred, this occurred on which body? This occurred on B. Force from A was exerted on B. So the force is being exerted on B, right? Now second force is being exerted from B on A. Can you see two different bodies? It's not like, suppose I have taken a body and a force is acting upwards and a force is acting downwards, and they are equal in magnitude. They should just cancel each other. They should just balance each other. No. This is occurring in the same body, so they will be canceling each other. But these are two separate bodies, no? One force is occurring on A, one force is occurring on B. The reason is that, this is the reason why the forces are not able to cancel. But law still remains there, right? So what is the third law of motion? It says that to every action, there is an equal and opposite reaction. All right, action and reaction are instant forces. Now see, they both are instantaneous. And action and reaction act on two different bodies. That's why they do not cancel each other. Now, one thing, when a person walks, there is a case, there is an example actually in your textbook, only this is written in an elaborate manner. Forces that act when a person walks. Now see, whenever, if a theoretical question comes to you, to write the laws of motion and describe all of these. So see, straight away, you will mention all the three laws. But what if a specific question comes from this part only, third law of motion, then for third law of motion, you have to give this example, because there's a very good example. So it's preferable to give this example whenever it's used. Now see, when a person is walking, suppose this is a person. Let's assume this is a person. Now what happens whenever two objects are placed in contact with each other? Did I mention normal reaction in the last class? Let me tell you, even if I have. Whenever two objects, suppose this is one table, let's say. On table, I have kept one object. So because they are kept in contact with each other, one contact force exists upwards, that is perpendicular to it, away from the body. It exists away from the body like this. This exists away from the body. So one normal reaction will always occur. Whenever two bodies are placed in contact, a perpendicular force occurs opposite to the direction of body. This is a contact force. We call this as normal reaction. So here, when the person is walking on ground, whenever we walk on ground, our feet also touch the surface of the floor, touch the ground, right? They also touch the surface of the floor. So it means upwards, a normal reaction will be there. All right. Now see, when you heel strike, when your heel strikes on the floor, right? When you are just tapping your heel on the floor, how do you walk? You first there's a heel strike, then there is a mid stance phase that comes whenever we are walking. So whenever you are striking a heel, as soon as, so what you're doing, you are sending a force on the ground. See, whenever because of heel strike, there's a force on the ground. There is a force on the ground that it comes. Now see what happens to this normal reaction. If the normal reaction is occurring upwards, so because of the normal reaction, we should be pushed upwards, but we are not flying. We are always stuck to the ground. Reason? Gravity. Because gravity is also there. So one gravitational force will always exist. And direction of this gravitational force will always be downwards. I'm not doing this in detail because you have a separate lesson, gravitation. There we'll study this in detail. Gravitational force, you will be calculating the formula also by yourself. Anyways, so why aren't we pushed upwards because of the normal reaction? Because of the gravitational force. There is an equal gravity that is occurring downwards, normal reaction is occurring upwards, so we are able to walk. But when we are striking the heel, then we should just be pushed off the ground. The reason is that Newton's third law helps us. When the force is being exerted on ground, there is a reaction that ground also sends on us. There is a reaction force of ground. Reaction force of ground. Fine, there's a reaction force of ground. Suppose, let's say, it will also resolve itself. Suppose this is R. Let's say this is theta. Resolution of vectors we have studied. This will become R cos theta and perpendicular one will become R sine theta. Like this, it will be distributed and this helps us in balancing. Basically, this balances the weight. This reaction balances the weight along with the normal reaction. And what happens to R cos theta? This helps us to move. When you have striked up the heel, there's a reaction force, then you are pushing your body forward. So R cos theta basically helps to move. Right? This helps a man to move. So this is all these components are what? These are basically forces that are occurring, right? These are basically forces that are occurring. When you have tapped the heel, there's a reaction you have sent, but we have studied Newton's third law that to every action, there is an equal and opposite reaction. So action was done on ground, reaction came on us. So that's why they will never cancel each other. Apart from there, if you resolve them, if you resolve these forces, you will understand how these forces are helpful for us to move. So a person walking on ground is the best example you can give whenever you have to write about the Newton's third law of motion. And this is very important, action and reaction, why don't they cancel each other? This question also comes a lot in your small marker questions, 1 marker, 2 markers. Why do actions and reactions not cancel each other? Fine, note it down, then we'll study impulse. Impulse is related to this only. Now let's talk about impulse. See what is meant by impulse. Impulse is actually a force only. Force that we have been studying, impulse is also a force. It's just that force that acts for a very small duration of time that we call as impulse. Let me give you an example. Suppose a ball is being thrown and it is being hit with a bat. So when the ball is thrown and it is hit with a bat, there is such a small duration. See, force acts on the ball. When the bat hits the ball, there is a force that acts for a very small duration. Yes. When the ball hits and when the bat hits and the ball moves in the other direction, there's a force that acts. But see, it acts for such a short duration of time. So in that case, you won't call the force as force. You will use the term which is known as impulse. Or another example, when hammer strikes the nail, you have fixed a nail. You are striking it with the help of hammer. So when this is how we strike, right? You do not place it for a long duration of time. You just keep on striking like this. So see, when you have struck the hammer, when the hammer is being struck, the hammer exerts a pressure, exerts a force on the nail, because of which the nail moves inside, right? So that force is occurring, force that acts from the hammer to the nail, but it is for such a short duration of time because we move our hand backwards, right? So now instead of calling that force which is acting for a short duration of time, because how will you define it? Every time you'll have to then specify that this force is acted for a short duration of time, this force is acted for a short duration of time, right? So instead of just mentioning it that this is acting for a short duration of time, simply say the fact that this is an impulse occurring. So forces that act for a very short duration of time, we have a special name which is known as impulse. Fine. Impulse is a force that acts for a short duration of time. I'll tell you with the help of graph. See, this is force versus time graph. So there is no force, nothing, nothing, nothing. Suddenly there is a large force that occurs for a very short duration. You can see just for this time span. And this is actually a variable force. This is a variable force. That's why this is changing with the graph. All right. This is a variable force. Maximum value is achieved and suddenly zero. Like when the ball was hit with the bat, when the bat and ball touched each other, when there was a force, the contact force occurred, it was for a very short duration of time and the ball then changed and deviated. All right. So impulse is what? Yes. When bat strikes a ball, when hammer strikes a nail, impulsive force, force which acts for a short duration of time. Impulse, it is the total impact of impulsive force. It is the product of average force and time of contact. So everything we do not define physically only, we have mathematical formulas also. So impulse, this is represented by the symbol I, and since this is a force, this is a vector quantity, keep in your mind, class. Okay. So this is product of whatever average force that has occurred, basically the force multiplied to the time of contact. This is what? This is the time of contact. That very short duration of time, let it be 2 milliseconds, 3 nanoseconds, 1 second, like this, let it be, but that time you will multiply. Okay. And one more thing, see, what is average force? Basically, the average force, this means that I'm talking about force only. We studied that this is rate of change of momentum, or I can write it as change in momentum by change in time, right? This is what? This is change in momentum. Change in momentum. And this is a time duration. This is time duration. So let me put the value of force here, right? So if impulse is equal to force into time, and force is momentum by time, so time will get changed. So basically impulse is rate of change of momentum, change in momentum, not rate, because time has cancelled. This is just change in This is just change in momentum. So impulse can also be defined as change in momentum. And whatever direction of force, since this is the force that is being applied, so direction of force will be there, and it's a vector quantity. Secondly, it's force into time. SI unit of force is Newton times SI unit is second. So SI unit will become Newton seconds. We'll see a question based on impulse. Impulse and momentum we'll use. This relation will be used. Impulse is equal to change in momentum. Note down this. Then I'll discuss the question. Then we'll move on to a new topic. See, this question says a ball has struck the mirror. 5 kg is the mass of the ball with a velocity 10 meter per second. When it comes in contact, it rebounds, right? It comes in contact and it rebounds, bounces, bouncing of ball. So the direction of velocity changes. That's why we have to be careful. We have to find out impulse and time. If time of contact is given, we have to find out average force. See, if we know mass of the ball, we know the velocity of the ball. Which is the quantity according to you that you think we'll be able to find it out? How should we proceed with the first part? Yes, anyone? Because average force is not there. Average force we'll calculate in the second part. So how will we calculate impulse? Shaista? Any answer? Yes, any method you think? One hint. Look at this. You have written one more formula also. 2 formulas of impulse we have written. If we do not have the knowledge of average force, we do have one more formula. Change in momentum. See, mass is given, velocity is given. Here also mass is given, velocity is given. It's just that velocity's direction is different. But at least we'll be able to calculate momentum, and change in momentum means the initial momentum minus the final momentum will give us impulse. Once you have impulse, time of contact is there, you will be able to calculate the average force. Clear how to proceed with this question? See, let's take one direction as positive, other direction as negative. Let's take this right side as positive. So automatically this left side will become negative. Keep in mind, this is a vector quantity, so you have to apply the sign conventions. So impulses change in momentum. So what do we basically have to find out? P2 minus P1. What is P1? Mass into velocity. Mass is 5, velocity is 10 plus 10. That becomes 50 kg meter per second. When we are talking about this, second one, P2, mass into velocity. This is 5 into minus 10. So that becomes minus 50 kg meter per second. Coming to change in momentum, what is P2? P2 is minus 50. Then this minus sign, then P1, P1 is 50. So what is the change in momentum, which is equal to the impulse? It's minus 100 kg meter per second. This you can write it as kg meter per second. You can write it as Newton seconds also, because both the units are in SI form, standard form. Since it is equivalent to momentum, that's why we can replace its value, its SI unit. Second part, see, impulse we have calculated minus 100. Time is given as 0.2 seconds. Can we calculate the average force? I is equal to force into time. So force is I divided by T. So force is minus 100 divided by 0.2. Force becomes minus 500 Newton. This is telling you that force is acting towards the left, because our sign is coming minus, no. This negative sign is telling you the direction of forces towards. One more question we'll do. This was just straight, horizontal. If angle is there, how we will handle the question, that we'll just see. Then we'll move on to the new topic. See, in this question, same thing is occurring, and mass and velocity are just mentioned with as m and b. It's just that now instead of striking horizontally, the ball has been striking at a certain inclination or a certain angle. So here what we'll do, if we have this as the mass, there is a velocity which is acting downwards. So we'll resolve the velocity along these two directions, x and y axis, because you cannot solve on an inclined plane, right? So when we are having this, see, if this is theta, this will also be theta, alternate angles. So what have we studied in resolution of vectors? That the axis with which the angle is made, it is termed as cos theta. So this becomes v cos theta, and perpendicular to it becomes sine theta. This becomes v sine theta. Fine. Again, velocity is occurring here. When it is rebounding, it is bouncing back, the velocity is occurring here. So one component will be here. One component will be here, one component will be downwards. See, if this is theta, this will also be theta, corresponding angles. So again, if this is theta, so this axis will receive cos component, cosine, v cos theta, and this becomes v sine theta. Now see again, class, you have to choose a sign convention. Take this as positive, this as negative. You can choose any sign convention. Let's go by the previous sign convention. We are taking right words as positive and left words as negative. All right. And let's, because both of them are occurring in the same direction, let's take down as positive. Up and down is also there. No, right now you are having sign component also. So you have to take the sign convention along y-axis also. Now we'll resolve this time because we have two axes, x and y. In the previous question, since no angle was given, so we just calculated directly with the help of x-axis. Now we'll be calculating x and y separately. So this will be momentum along x-axis, second one, minus momentum along the first one. Momentum P2 minus P1 along x-axis. So M, P2, which one is coming back? Velocity along x-axis while rebounding. So this becomes minus V cos theta, right? This is P2, velocity, mass into velocity. So this becomes minus V cos theta. Then this minus sign. Then P1. This is plus V cos theta. So this becomes minus MV cos theta. So this becomes minus MV cos theta minus MV cos theta. That becomes minus 2MV cos theta. This is just along x-axis. Now we have to find out the change along impulse, final minus initial, but this time we'll be considering it as y. So both are sine theta, MV sine theta minus MV sine theta, because both are positive. So they will cancel each other. Impulse along y-axis is coming 0. So what is the net impulse? If we are talking about the net impulse, this will be Ix plus Iy. Since Iy is 0, net answer is minus 2MV cos theta only. Note it down, then we'll see now pulley mass system. See, pulley mass system, you will have a separate question on pulley mass system. So pulley is kept and a single rope is tied. All right, this is a single rope. So all the forces that will act within the rope will be the same over this side or this side. So do not take the variables different. Now, what all forces will be acting? One new type of force that we'll be talking about is tension. Tension is a force that acts on strings, on threads, on strings, on wires, on very objects with very thin, narrow diameters, like wires, mainly threads or strings or ropes like this. So which have a very small diameter. So what is the direction of tension? Tension is a force. Exactly. Whatever you've studied about force, tension is exactly that. It's just that a special name to the force that acts in strings or ropes or in threads is given, which is called as tension. So direction is away from the body. Suppose this is a string. See, this is the same rope, which is slid over this. And this is the mass M. M1 is a block. Let's say M2 is greater than M1, suppose. So tension will be acting away from the body. So this is the direction of tension. Here also away from the body. So this is the direction of tension. We will not take it as T1 and T2 because this is the same rope. Suppose in the question it mentions that two different ropes are there, though it's not possible in a pulley. But if let's just suppose it is one single, instead of one single rope, two ropes are given. So then you will take it as T1 and T2. Otherwise, this is single T. Usually in all the questions that are given to you, T is given. Now, F is equal to mg, right? F is equal to ma. And acceleration that acts vertically, we know is known as acceleration due to gravity. So force will become F is equal to mg. So a downward force will act, which is m1g, and this will act m2g. Now, why did I say let's take m2 greater than m1? Because one will go up, other will come down. That happens in a pulley, right? So here acceleration will be upwards, right? Why acceleration will be upwards? Because body is moving upwards, velocity is upwards, so acceleration will also act upwards. Always take the direction of acceleration as positive in these pulley mass example. Not always, just in pulley mass example. And here what will happen? This body is coming down. So here downwards you will take positive for this segment. Now a concept which is known as free body diagram that will help us in the calculation. So yes, sign convention, forces acting in the direction of acceleration are taken as positive, and forces that are taken in opposite direction of acceleration are taken as negative. Net mass is mass of body into acceleration. Now see what is meant by this. When I'm talking about the first block, mass of body into acceleration, that is what is the net force, right? What is the mass of body? m1. What is the acceleration? A is equal to. So net force, what is the net force? Tension is also occurring, m1g is also occurring. So both forces are in opposite direction. So should it be T minus m1g or m1g minus T? Anyone? T minus m1g or m1g minus T?
T minus m1.
T minus m1g. Very good, Shaista. Because acceleration is acting upwards. So upwards will be positive for us. So which force is acting upwards? T. So this becomes T minus m1g. That's it. Here you don't have to go into the details. This is it, what will be coming in the exam. M1A, this is the total force, net force. So what is the net force equal to? Net force is equal to above force minus below force. Got it? Why are we writing this equal to M1A? M1A is equal to T minus M1. Come to the second block. What is the net force? Net force is M2A. Now see, acceleration is acting downward. So this time M2G will be positive, tension will be negative. So that becomes M2G minus T. Now you have two equations. This is one equation. This is second equation. Whatever question is given, put it in the equation. You will be able to find out the variable. Usually it's given tension and acceleration are asked. Using these two equations, you can count. Now, I just want to discuss free body diagram with you. Free body diagram is that, see, right now I have just seen the diagram and I have drawn it. What if other forces are acting? How will I, for our precision, know what we take? We take the body separately. We take the body separately, like M1. I'll draw M1 separately. Now forget everything, anything, any object, anything that was present beside M1. Whatever forces are acting on M1, I will write it down. Suppose here I remember tension was acting. Here I remember M1G force was acting. So this is the FBD. This we will call as free body diagram of M1. Suppose I'm talking about M2. So here also, as we remember, tension was acting upwards and M2G, this was acting downwards. So this is what? This is free body diagram of M2. Clear? This is what is meant by free body diagram. Suppose this right now, I have not taken it. Suppose this setup is put in water. So in water, you have one more force that pushes things upwards. We'll study though, buoyant force. So if suppose this is acting, so we'll write it like this. If any other force is acting. Suppose this block was kept on a table. So normal reaction also we'll keep. Whenever we are drawing free body diagram, all the forces which are acting, you have to write it separately. All right. All this will come back in friction. So because since we have not done friction right now, this is just enough. Make a separate heading as pulley mass system. Write it down. If time is there, then I'll start friction. Now friction is only left your lesson, because rest of the part I'll do a combination of entire circular motion which is present in your work energy and power, rotation motion, laws of motion. So altogether one circular motion we'll do. But friction we have to complete before that. See, can we have a class tomorrow at the same timings? If you all are available, because I want to complete friction by tomorrow. So at least by this week, half of circular portions will also be started. Just type yes or no in the chat column. Same timings tomorrow, an extra class just for tomorrow. Then we'll have a class on Thursday also. So if we'll have 3 days consecutively, we'll just reach towards the end of this lesson. At least tomorrow friction will be over. Yes, available or not? Fine by all of you. Abdul, Khadija, Lina says yes. What about others? Khudeja, Shaista, Mariam, okay. Khudeja and Khadija and Abdul. No issues? Abdul, Khadija, Khudeja, Bashir. You people are present or not? At least reply yes or no in the chat column. Khudeja, yes. Khadija is also available. Abdul, what about you? Everybody has answered. Okay, and anyways, then if Abdul is not responding, then we are having a class tomorrow, same timing, just an extra class. At least we'll complete a major portion of friction. Friction is not a very lengthy topic. Write it down. All those who have completed, you people can leave. Now we'll continue tomorrow. Okay, thank you so much, class.